The example 2 maybe is a little bit more complicated because it's a constant form. We have a denominator. We cannot divide by 0, meaning that this cannot be 0, meaning that x cannot be 1. When we derivate this one, we have to use the constant rule. We simplify it, it comes back to here. We check, but still the discontinuity point is same 1, so this is enough for us. When we start solving with zeros, all four will look more complicated, but it can be 0 only if the numerator equals to 0. So from here, we can easily solve that x is either 0 or x equals to 2. And when I do the table, I basically do it a little bit differently than what I have here. So I put all the values what I have found. I have 0, 1, and 2 in ascending order. 0 and 2 are zeros of a derivative. So I have a normal vertical line under them. But because 1 is a discontinuity point, I have a dashed line there. It's not required, but it reminds me that this is special point. You have to be careful with this one. When we start checking the function and we start with the derivative case, here, this is our derivative. If you check the denominator, it's squared, meaning that it's always positive. It cannot be even 0 because we cannot divide by 0, so it's always positive. So the only thing affecting the signs is the numerator, which once again is parabola upward with 2 zeros. In the middle we have this dashed line, but still values are positive, negative, negative, positive. So we know the signs. We know how the function is behaving. This is not the reflection point I was talking at the beginning, because this one is discontinuity point. The reflection point minus minus or plus plus, this should be the 0 of a derivative, and that is not what happens here. So here we know that at 0 we have a maximum, and at 2 we have a minimum. We know nothing about the value at 1. So we know the local maximum, we know the local minimum. And if we check the graph, which is drawn here with the GeoGebra, you see here is the maximum, you see here is the minimum. Value at here is much more than at here. So this function is actually in 2 parts. And if you just check the value at 0 and the value at 2 and make the decision based on that to say which one is maximum and which one is minimum, it would be totally incorrect.